everyone, welcome to another episode of Enly Academy. Now in this episode, we are going to talk about how to handle race condition when you are working with DynamoDB. Some of you might have not experienced this particular issue, but some of you might have already experienced it, particularly if you are working with high throughput data. Now let me take you through a scenario first, and I will explain the issue here. Now imagine you have a browser and that is connecting to your API gateway. So you may have a front-end application and it's connecting to API gateway. Let's say this is a HTTP GET request. And we are requesting for an item with an ID of 100. So the API gateway has a GET method, and that method will invoke a Lambda function, and this Lambda function checks if the information is available for this particular item with an ID of 100. So it will check whether the information is already available. If not, it's gonna call a third-party API, fetch the data. So this is the number 5 is fetching the data, and then store that particular information in DynamoDB, and then send the response via API gateway. So the browser here, it's synchronously waiting for that particular information, because as you can see, there is no any queue or any event brokers that will decouple this request and response. So it's always calling this API gateway and synchronously waiting for the response. Now let's imagine the same browser client or a different browser client make another GET request with the same ID 100. Now this happened after the first request. So then the API gateway again invoke this Lambda, and now it checks whether that information is available for the item that has ID 100. Now in this case, it finds out the information is available. So then it's not going to call the third-party API, and it will return the data immediately because it has earlier persisted that data in the DynamoDB. Now this is like a caching mechanism. So you don't always have to call the third-party API. So when you call it and when you get the response, you store in DynamoDB. So you'll first check your cache or the database if the data is available. If not, only you call third-party API. Now there could be many reasons as to why we do this. One reason could be this third-party API calls are costly. So there's a subscription or something, and we have to pay for these API calls. And also there's a delay, right? So this is the third-party API connecting through HTTPS, and there's a delay, the network delay is added. So you can always cache the data, so you can quickly fetch the data and respond if data is already available. Now this will work without an issue when the throughput is low. But imagine you are requesting for this particular item, ID that equals 100, with high frequency. Now imagine there are like multiple browser clients and they all are making this call. Now in this case, since most of this request is received by the API gateway, more or less at the same time, there will be multiple Lambda invocations. Rather, there will be parallel Lambda invocation. So there will be multiple parallel Lambda invocation that is invoked by the API gateway. So what all these Lambda functions do, they check whether the information is available in the DynamoDB. If not, call the third-party API. Now imagine when this Lambda invocation checks the database whether the information is available for this particular item, it is not available. So it makes the call to third-party API. Now as I previously described, once the data is received, only then we update the status and the data here. But in the meantime, the other Lambda functions are also checking whether the information is available, and it is not available because there's a latency between these responses, right? So therefore, they will also make the call to third-party API. Although we expect we call this third-party API only once and then use the information from the DynamoDB cache, that is not the case. Now here the obvious reason is this latency, So the response takes some time to get to the Lambda again. Now imagine the response time is also minimum. Now even in that case, we will fetch the data and then we will update it. Now in DynamoDB, the latency is in single digit millisecond. That is given that you design your DynamoDB data model properly. If you have a bad design, then it will take more time, like 20 milliseconds, 30 milliseconds, so on and so forth. So in such a cases also, when one Lambda function is writing to the DynamoDB, and let's say it takes about 20 milliseconds, in that meantime, another Lambda function is requesting for the data. So at that time, the data is not yet persisted. So still, this Lambda function will receive the data is not available, such that it will invoke another third-party API or so. So you see, this is the race condition, because all these Lambda functions are invoked almost at the same time in parallel. So there are multiple concurrent requests to the DynamoDB, and DynamoDB itself has some latency. And also if you have such third-party APIs and there are latencies, then it will add to the time to update these messages in the DynamoDB. Now, because of these reasons, you may encounter some unexpected behaviors in your application. So how do we prevent this, or how do we at least mitigate these issues? So that's what we are going to discuss in this video. Alright, now there are multiple ways we can mitigate these concurrency issues. So one of the ways is to use conditional updates. Now as you may know, DynamoDB supports conditional updates. That means you can update certain attributes in your item in the DynamoDB, provided certain attributes meet an condition. For example, let's take the same scenario. Now in this case, when the API gateway receives the request, it will invoke the Lambda function and then it fetches the data. So it checks in the DynamoDB cache. Now in this case, let's assume the data is not available. So here the record only has the status pending and the data is null. So what can we do here? Before calling the third-party API, we can do a conditional update. We can update this status as processing, given that the previous state of the item is pending. So that's what we do here. We are doing a conditional update at step number 4, and we will set the status to processing, given that the previous status is pending. And after that, it's going to make the third-party API call, and once the response is here, then at step number 7, we are going to update the data and also the status to completed also. And after that, we will return the data to API gateway and so on to the browser. So how is it going to mitigate our concurrency issue? Now let's imagine multiple Lambda function invocation try to fetch the data and they all find out there are no data available and the status is pending, the original status of the item, and the data is null. So they all try to update it. However, when you're using conditional update, the conditional check and the updating is an atomic operation. So this means that no other write operation can modify this particular item between this condition check and the update. Only one of these conditional update will get succeeded and the other conditional updates will fail, and we can catch that. Now once there's a conditional update failure, then we can decide what to inform the client. Probably we can ask them to retry it. But however, if the conditional check is succeeded, then we can go ahead and call the third-party API, fetch the record, and update the status and the data here. So next time when these guys retry it, it will check whether the information is available, and in that case, maybe the status is completed and the data is available, and it will then get the data from the DynamoDB cache and send it back to the browser. So therefore, for a given ID, we only call the third-party API once. Now there are other ways that we can handle these type of concurrency issues, like acquiring a lock and then setting a TTL for the lock, so on and so forth. But this is a straightforward way where you can use these conditional expressions in DynamoDB to handle concurrence issues. Alright, so now let's have a look at the code I prepared for you guys, so it will be more clear to you how I have implemented this solution. Now, by the way guys, just one small thing. You can obviously use caching in front of the Lambda function. Could be at the API gateway level, or you can even have a CloudFront distribution in front of API gateway. Okay, so your browsers clients are calling CloudFront, and then the CloudFront proxies a request to API gateway, so on and so forth. So in these cases, you can define your cache policy, like you can define your cache key, what your cache keys consist of. For example, it includes path parameters, query strings, so on and so forth. So based on that, CloudFront decide if it's the same request. If so, it will send the response to the client right from the CloudFront itself. But in this episode, I don't want to focus about the caching, but I want to discuss about how to handle concurrency issues when you're working with DynamoDB and AWS Lambda. All right, so let's get to the code. So I have a Lambda function and I call it status checker. And this Lambda function is getting invoked by an API gateway. So you can see I have an event. By the way, I'm using serverless framework here. And it's getting invoked through a API gateway. And I deploy this Lambda function. So it looks like this in AWS console. So we have Lambda function and it's getting invoked by API gateway. So what does this Lambda function do? So this Lambda function is going to get the request from API gateway. So this is the handler function. So it's going to extract the ID from the path parameter. So in the API gateway, we will have a path and we are going to set ID equal to maybe 100. And then we get that ID value. And here, as we already discussed, we are going to get that record, if at all existing, in the DynamoDB. So here I'm using DynamoDB get operation to that particular table name with that particular ID, and I will check whether the data is available. So I have this item, and if that item is present, I will just check if the status of that particular item is completed. So if the item is the status is completed, that means I have already fetched that information from the third-party API and saved the data. So in this case, I log this message, status is completed, and also I'm going to return it from that Lambda function, the data for that particular item.data. However, if the status is processing, I will talk about how we are going to add this status. So if the status is processing, then I will say, okay, the status is processing. So that means like another Lambda invocation is already processing this. So in this case, I will just return item is being processed, maybe retry again. However, if the status is pending, this is one of the original status. So what I'm going to do is I'm going to do that conditional update, the one I just talked about. So in this case, I'm going to set the status to processing. So I'm going to set the value of the status attribute. So as you can see, status is status and the processing value is processing. So I'm going to set that value to the status attribute. Given that the existing status, so I have the condition expression. Look, so I have this condition expression. I will just check the status is pending. So you can see hash status is status, :pending is pending. So essentially, I'm just checking if the existing item status is pending. If so, set the status to processing. And here in a try catch block, I will do this update. And if there's any failures, let's say the conditional check failures, I will get an error and I will just check the error code, whether it's a conditional check fail exception. If so, I will log a message conditional check fail, and also I will like return 409 with the message conditional check failed. Now here also you can ask the client to retry it. Maybe instead of setting the status 409, I can set 200 conditional fail check, please retry. So that's the code in the Lambda function. And in my serverless configuration, I have created this DynamoDB table. This DynamoDB table name is status table, and it has the key attribute, or the partition key is ID, and that's all it is. So let me quickly show you the DynamoDB. So this is the DynamoDB table, status table, and it has this partition key ID, it's 100, and its status is pending. So this is the only item that I have right now. All right. So now in addition to that, I also have a test script. Now this test script is essentially calling this get API URL, and then I'm calling this path check status path with an ID of 100. So here when I was defining my Lambda function, let me quickly show you. So this is my Lambda function status checker, and the path is check status, and so that's the path that will be appended to the API gateway URL. So that's why I added check status here, and then I added this query string. So what happens here? Our Lambda function is going to get that query string and then try to see the data is available and try to fetch the data. And depending upon the data is present or not, it will go ahead with the rest of the logic. So here in this test script, I'm going to make some concurrent requests. You see, I'm going to make 20 concurrent requests to the same API URL with ID of 100. And I'm going to issue them all at once. See, I'm doing a promise.all. So concurrently, I'm issuing this request. So let's see how the behavior is. Is it going to call the third-party API? So how do we know if is it going to call the third-party API? Let me quickly show you that as well. Now here, when the status is pending, when the item status is pending, I'm going to make that third-party call. So here I try to update the status to processing. If that is successful, look, I will do the update first. And if that is successful, I'm going to call my third-party API. So here I have a mock API function. So this is nothing but returning this data, mocked API data with 2-second delay. So this is simulating an API call. So after that, once I got the response here, that means mock API data as the response, I will get it. And then I'm going to update that item. So again, so this is the second update. So ID is ID. And here I'm setting the status to completed because now it's no longer processing, it's completed. And also I set the data to data, which is mock API data. So that's it. And finally, I'm going to return the 200 and the data I received from the mock API. So let's test this. Now, first, I want to do this testing without this conditional update. So you see, I'm doing this conditional update to processing, like setting the status to processing. I don't want to do that. So let me comment it out, right? So essentially what happens here now, when you get the ID, you fetch the record. If the record is completed, the record is available and status is completed, we return that data. And if it is pending, we are just going to call them a third-party API and then finally update the status to completed. That's all we do. So let's see how will this behave when we make concurrent requests. So I'll do SLS deploy. All right, so it is updated. So now I'm going to run my script. So my script is going to send 20 concurrent requests to the API gateway URL check status with the ID of 100. So let's do that. Node test.js. Look, all the 20 requests, I received mock API data, mock API data. So this is all good. So I got the data from the Lambda. But let's see in the Lambda level what actually happened. So I'll go to this function and in the monitoring section, let me do last 15 minutes and refresh it. The data is still not available. So the invocations are still not showing up in CloudWatch. It takes some time. Now here we go. So in our monitor section, if we go to this concurrent execution, I can see we have received 20 concurrent requests. So there were 20 Lambda invocations happening in parallel. So I'll go to DynamoDB and then do a refresh. Good. So I see the data is updated as mock API data and the status is also updated as completed. Now, how many of these Lambda invocations that happen in parallel invoke the mock API? So let's have a look. So for that, I will go to CloudWatch logs and I will click this button, View in Log Insights. Here now I can run a query to filter the log message that I have given here. So here, whenever I'm making a call to the third-party API, which is this method, then I'm logging this log line, calling third-party API. So let's copy this text, and then I'm going to search for this particular message. And here it has to be message like. Filter message like this. There you go. I got 20 records matched. If I expand this message section, so it's saying calling third-party API, calling third-party API, calling third-party API, like all our 20 invocation. Now look, the invocations IDs are different. So this is starting from D1 and 0, B2. Likewise, like all these invocations are different invocations. Now these are the parallel invocation. Now each invocation call our third-party API. So what happened there? So every time when there's an invocation, it tries to fetch that data. It is not available. It calls the API, get back, and then try to update it and send the request. So it's all, so each and every parallel invocation called the third-party API since it couldn't find that data in the DynamoDB. So this is the one we want to prevent. Now, let me go to this function and I will delete the logs. So there are now 41 log streams. Yeah, I'll just delete it. All right, all the logs are deleted. Now, if I run the same query in the login side, I shouldn't see anything because now the logs are removed. So it's 0 out of 0. Okay, now I'm going to go ahead and enable our conditional update. So here I will uncomment it. So I'm going to do a conditional update first, and then only I'm going to make the API call. So let's do a deployment. So let's deploy. Okay, so deployment is completed. But before running our script, I need to set the status in the DynamoDB. So here right now, this is the item status, like, ID 100, the status is completed. I need to make it to pending, and I will remove this data attribute because this is our original state. Okay, so I have an item with 100 status pending. So now I'm going to go ahead and run our script. So let me do node test.js and let's see what the response. So here, all of these invocations I get, item is being processed, retry again. Only one of these requests return the mock data. Look, this one. Everything else asks us to retry again. So if I do a retry now I get all the mock data. So what happened here? So in this case, so one of the conditional updates succeeded, and that went ahead and called third-party API, got the response and sent it to the browser so that we see that in one mock data API response rather. The others, they saw the status is processing. It just sent this item is being processed, retry again. However, in this case, we didn't see this conditional check fail. That means no two requests try to update the status to processing at the same time. Now this could happen, by the way. This can happen really. Okay, now let me show you the CloudWatch logs. So here, I'm gonna run the same log insight query. Let's see how many times have we called this third-party API. There's only one time. Look, calling the third-party API. Now let's see if we can create that conditional check failure. So what I will do here is I'll remove all these log streams. Delete. Okay, now it's nothing. And also reset the item. By the way, the item is also updated. There was one invocation to the mock API, and before it passes the data back to the client, it updates this data attribute and the completed status. So let me remove this and then set to pending. So let's see if we could simulate that conditional check. Now this is the nature of REST condition, so we can't like particularly test for it. Let's run it and see. There you go. Now this time I see conditional check fail, please retry. And item is being processed, retry again. Look, now this time 3, 4, 5, 6. Yes. So this 6th request, including this 7 request, happened almost at the same time, and they all found that the item status is pending and they try to update it. So our conditional update only succeeded this request. The others ended in the conditional check fail catch block. Now if I do a retry now, I will get the mock API data. Now that the data is updated in the DynamoDB, it is returned from the database. Let me do one last query. So let's see how many times our calling the third-party API happened. Only one time. There you go. All right, guys. So this is what I want to show you. So this might come in handy when you have these REST condition issues. Thanks for watching. I'll see you in another video.